Hello, and welcome to Boring History for Sleep. Tonight, we gently unravel the quiet story of a seemingly inconsequential aspect of our homes, yet one that profoundly influenced comfort, energy consumption, and even the very stillness of our interior spaces. We contemplate the humble weather strip, specifically those designed for exterior residential doors. Imagine, if you will, the subtle interplay of material science, economic pressures, and an evolving understanding of thermal dynamics, all converging to shape something most of us never truly observe, existing in the liminal space between inside and out. It's a tale not of grand battles or towering achievements, but of minute increments, of gradual improvements in the art of keeping the outside truly outside. To truly understand its significance, we need to examine its origins and follow its painstaking progression through the 20th century. Our journey begins, conceptually, even before the turn of the 20th century, in an era where the concept of a sealed home was more aspiration than reality for many. Prior to 1900, efforts to mitigate drafts around exterior doors were largely rudimentary and localized. Homeowners often resorted to improvisation, strips of cloth, wadded rags, or even rudimentary felt pieces tacked somewhat haphazardly to the door frame or the edge of the door itself. These were temporary, often unsightly, and possessed limited efficacy. The primary objective was simply to block the most obvious gusts of cold air or prevent dust ingress. There was little in the way of standardized solutions, and the materials employed were typically those readily available and inexpensive. Wool felt, being a common textile, saw early adoption due to its inherent compressibility and its ability to somewhat conform to irregular gaps. However, its susceptibility to moisture, its tendency to compress permanently over time, and its relatively short lifespan meant constant replacement and maintenance. As the 20th century dawned, the increasing availability of manufactured goods and a growing emphasis on domestic comfort and, critically, fuel efficiency began to push the envelope beyond these ad hoc methods. The advent of central heating systems, while still a luxury for many, highlighted the significant heat loss that occurred through poorly sealed building envelopes. A drafty door was not merely an annoyance. It represented tangible financial leakage in the form of wasted coal or wood. This economic imperative, combined with advancements in manufacturing processes, laid the groundwork for the first generation of commercially produced weatherstripping profiles. In the period from 1900 to approximately 1920, the market saw the emergence of more refined felt-based weatherstripping alongside the nascent development of metallic solutions. Felt weatherstripping evolved from simple raw strips to pre-cut, often pre-creased rolls, designed for easier installation. These often consisted of thick, compressed wool felt, typically a 1/4 inch to a 1/2 inch in thickness, and perhaps an inch or two in width. They were still predominantly applied by tacking them directly to the interior doorstop or the face of the door jamb. The idea was to create a compressible barrier that would press against the door when closed. While an improvement over rags, these felt strips still suffered from the inherent limitations of their material. They would absorb moisture, leading to mildew or degradation. They would flatten over time, losing their resilience and thus their sealing capacity. They were also prone to tearing and required careful, continuous maintenance. Simultaneously, a more durable and arguably revolutionary approach began to gain traction: metal weatherstripping. Early metallic weatherstripping designs were often intricate and required skilled installation. The primary metals utilized were zinc, bronze, and occasionally brass, chosen for their malleability, corrosion resistance, and relative strength. These early systems were characterized by interlocking profiles. A common design involved a strip of metal attached to the door frame, often with a U or J shape, and a corresponding strip attached to the edge of the door, featuring a hook or lip that would engage with the frame-mounted piece when the door was closed. The principle behind these interlocking metal systems was to create a convoluted path for air. Instead of a simple compression seal, air would have to navigate a series of bends and obstructions, significantly reducing its flow. Zinc, being relatively inexpensive and easy to work with, was a popular choice for these systems, particularly for the more basic residential applications. Bronze, a more costly but significantly more durable and aesthetically pleasing option, was often reserved for higher-end homes or commercial applications. Installation of these early metal systems was a specialized trade. It involved precise measurements, careful cutting of the metal strips, and meticulous attachment using small nails or screws. The installer would need to ensure that the metal pieces aligned perfectly when the door was closed, creating the desired interlocking effect without causing excessive friction that would impede the door's operation. Misalignment could lead to binding, squeaking, or, conversely, inadequate sealing. The subtle curvature and precise bending of the metal were crucial for optimal performance, allowing for a slight spring action that maintained constant contact while permitting the door to open and close smoothly. By the 1920s, with the economic boom and increased demand for modern conveniences, the sophistication of weather stripping solutions continued to advance. The concept of spring metal weather stripping became more widely adopted. This typically involved strips of thin, resilient metal, often bronze or zinc, formed into a V-shape or a similar compression profile. These V-strips were designed to be attached to the doorstop, with the V pointing towards the door. When the door closed, it would compress the V, creating a continuous seal along the length of the door jamb. The inherent springiness of the metal ensured that contact was maintained even with slight variations in the door or frame. These V-strips represented a significant step forward in ease of installation compared to the more complex interlocking systems. While still requiring careful measurement and cutting, they were less prone to installation errors that could render the system ineffective or cause the door to bind. The common installation method involved nailing the flat leg of the V-strip to the doorstop, ensuring the V-shaped compression flap extended towards the door edge. The heads of the small, thin nails were often countersunk or barely protruded to avoid interference. During this decade, door bottoms also began to receive more dedicated attention. The gap beneath an exterior door is often the largest and most persistent source of drafts. Early solutions included wooden thresholds with a simple beveled edge, sometimes accompanied by a fabric or felt strip tacked to the bottom edge of the door itself. However, these were often inadequate. The 1920s saw the development of more robust door sweeps, which were essentially strips of metal, zinc, brass, or bronze, with an attached piece of felt or rubber that would brush against the threshold when the door was closed. These were nailed or screwed to the interior face of the door bottom. The height adjustment was often crude, relying on careful initial placement. The economic downturn of the Great Depression in the 1930s had a twofold impact on weather stripping. On one hand, reduced disposable income meant that elaborate or expensive solutions became less accessible to the average homeowner. The emphasis shifted back towards cost-effective, often DIY-friendly options. Felt weather stripping, despite its limitations, remained a staple for its affordability and ease of installation. Manufacturers offered felt strips in various widths and thicknesses, often pre-packaged with a small quantity of appropriate tacks. The focus was on simple, utilitarian solutions. On the other hand, the Depression also fostered a greater appreciation for resource conservation and efficiency. Every penny saved on heating fuel was significant. This inadvertently propelled the market for more effective, albeit still affordable, weather stripping. Existing metal weather stripping systems, particularly the spring metal variety, continued to be installed, often by homeowners themselves or by local handymen seeking work. Manufacturers began to streamline their offerings, focusing on simpler, easier-to-install versions of their metallic products. The materials, however, largely remained the same: zinc and bronze for metal, and wool felt for fabric-based options. Rubber, while known, was not yet widely adopted for weather stripping due to cost and manufacturing challenges in producing suitable profiles. As the world approached the mid-century, the landscape of residential construction and materials science was poised for significant transformation. The onset of World War II, with its rationing and reallocation of materials, particularly metals, created a temporary hiatus in the development and widespread availability of metallic weather stripping for civilian use. Zinc, steel, and bronze were critical for the war effort, leading manufacturers to explore alternatives. This period, however brief, inadvertently stimulated interest in non-metallic options. Following the war, the booming economy and the unprecedented demand for housing in the United States ignited a fervent period of innovation and standardization in the building industry. The 1950s witnessed a rapid evolution in residential weather stripping, driven by new materials, improved manufacturing techniques, and a continued emphasis on energy efficiency and homeowner comfort. Aluminum emerged as a significant player in the metallic weather stripping market during this post-war era. Its abundance, lighter weight, excellent corrosion resistance, and lower cost compared to bronze and even zinc made it an attractive material. Aluminum could be easily extruded or roll-formed into a variety of profiles, facilitating mass production. The V-strip profile, previously common in bronze or zinc, was widely adopted for aluminum weather stripping. These aluminum V-strips were typically thinner gauge than their bronze predecessors, contributing to cost savings and easier handling. They were designed for screw-on or nail-on installation to the doorstop, with pre-punched holes often included to simplify the process for contractors and DIY enthusiasts alike. The screw heads were often designed to sit flush, maintaining a clean appearance and avoiding interference with the door. Beyond the V-strip, aluminum was also fashioned into more complex compression profiles. These might include an aluminum channel with an integral, sometimes replaceable, vinyl or rubber insert. These channel and insert designs offered superior sealing by combining the rigidity and durability of metal with the conformability and resilience of an elastomeric material. The channel would be screwed to the door frame, and the insert would protrude, compressing against the door edge when closed. The profiles of these inserts varied, from simple flat strips to small bulbs or fins. The 1950s also marked the increasing prevalence of elastomeric materials, particularly various forms of rubber, and the nascent introduction of vinyl. Foam rubber, both open-cell and closed-cell types, began to appear in weather stripping applications. Open-cell foam rubber, being more permeable, offered good compressibility but was less effective against moisture. Closed-cell foam, with its sealed internal structure, provided better moisture resistance and greater resilience. These foam strips were typically simple rectangular or D-shaped profiles, often attached with adhesive backing. Early adhesive backings were not as robust as modern versions and could degrade over time or in extreme temperatures, leading to detachment. For greater security, some foam weather stripping was designed to be stapled or nailed in place, often with a protective fabric or plastic coating over the foam itself. Vinyl, a synthetic polymer, began its journey towards ubiquity in the 1950s. Polyvinyl chloride, or PVC, offered an unprecedented combination of flexibility, durability, resistance to moisture and UV radiation, and cost-effectiveness. Early vinyl weather stripping profiles were relatively simple, including solid strips, small tubular shapes, or bulb designs. These were often extruded and could be easily cut to length. Their installation typically involved nailing or screwing them to the doorstop or the door face. The resilience of vinyl allowed it to conform well to irregularities and maintain a seal over a wide temperature range, surpassing the performance of felt and often exceeding the lifespan of foam rubber. The concept of a combined door bottom and sweep also matured during this period. Aluminum, again, played a central role. Aluminum door sweeps with integrated vinyl or rubber fins became a standard product. These were typically screwed to the interior bottom face of the door, with the flexible fins extending downwards to brush against the threshold. The multi-fin design was particularly effective, creating multiple barriers against air infiltration. The challenge remained in ensuring proper adjustment to accommodate variations in door height or threshold wear, without creating excessive drag when opening or closing the door. By the 1960s, the evolution of weather stripping accelerated, driven by continued advances in polymer chemistry, increasing public awareness of energy conservation, though not yet as prominent as it would become later, and a desire for maintenance-free building components. This decade saw vinyl solidify its position as a dominant material for weather stripping, offering a vast array of profiles and installation methods. The variety of vinyl profiles exploded. Beyond simple solid strips and tubes, manufacturers developed more complex extruded shapes designed for specific applications and sealing requirements. Bulb profiles, where a hollow or solid rounded section would compress against the door, became very common. Fin profiles featuring one or more flexible extensions were also widely used, designed to brush against the door edge or frame. J-strip, or kerf-in type vinyl weather stripping began to appear, where a thin fin of vinyl could be inserted into a shallow groove, a kerf, routed into the door frame or edge. This represented a significant step towards more integrated and less visible weather stripping solutions. The kerf-in method removed the need for exposed fasteners and created a cleaner aesthetic, while still allowing for easy replacement if the vinyl degraded. Foam weather stripping also saw significant advancements. Closed-cell foam, often encased in a vinyl or polyethylene jacket, became popular. These jacketed foam strips combine the excellent compressibility and insulating properties of foam with the durability and weather resistance of a synthetic exterior. They offered a softer, more forgiving seal than metal, and were less prone to noise or binding. These were typically adhesive-backed, with improved acrylic or rubber-based adhesives offering greater longevity and temperature resistance. Some designs integrated a rigid backing strip for nailing or screwing, further improving installation security. The 1960s also witnessed the proliferation of compression weather stripping, particularly involving a combination of rigid and flexible materials. An example is the aluminum channel with a vinyl bulb or fin insert. These systems were designed to create a continuous, positive seal by compressing the flexible element against the door or frame. The rigidity of the aluminum channel provided structural integrity, ensuring that the flexible insert maintained its position and proper compression. These were almost universally screw-mounted, offering a secure and adjustable installation. Integral weather stripping designs began to gain significant traction, especially with the rise of pre-hung door units. Instead of weather stripping being an aftermarket or on-site addition, it was increasingly incorporated into the design of the door frame itself. Door frames might be milled or extruded, with specific channels designed to accept a continuous gasket, often a vinyl or vinyl-clad foam profile. This factory-installed approach ensured a higher degree of precision and consistency in the seal, reducing installation errors and improving overall performance. The concept of the Q-Lon-style weather strip, though the brand name emerged slightly later, had its foundational roots in this period, where a resilient foam core was wrapped in a low-friction, durable polyethylene or vinyl jacket, allowing it to slide smoothly against the door while providing an excellent compression seal. Installation methods evolved to match the new materials and profiles. While tacks and nails remained viable for simpler felt or basic rubber strips, screws became the preferred fastening method for metallic and more robust vinyl systems. Screws offered superior holding power, adjustability, and the ability to remove and replace weather stripping without significant damage to the door frame. For adhesive-backed foam and vinyl, improvements in adhesive technology meant quicker, cleaner installations. Though careful surface preparation remained crucial for long-term adhesion, door bottom solutions also continued their trajectory of improvement. The common door sweep with a flexible vinyl or brush fin gained dominance. Furthermore, the 1960s saw the development and increasing adoption of automatic door bottoms. These sophisticated devices, typically integrated into the bottom edge of the door, would automatically drop a rubber or vinyl gasket to the threshold when the door was closed, and retract it when the door was opened. This eliminated drag and wear on the sweep while providing an excellent seal. They often involved a plunger mechanism that contacted the door frame as the door closed, activating the drop mechanism. Throughout this period, the standardization of weather stripping profiles and installation methods was a gradual, somewhat organic process. There wasn't a single overarching regulatory body dictating specific designs, but rather market forces, manufacturer innovation, and the practical needs of builders and homeowners drove convergence. Certain profiles proved more effective, easier to manufacture, and simpler to install, leading to their widespread adoption. Industry associations began to play a role in disseminating best practices and material specifications, implicitly fostering a degree of standardization. Let's delve deeper into the specific materials and their nuanced applications and limitations within our time frame of 1900 to 1970. Felt weather stripping, 1900 to 1970, with declining prominence. Felt, primarily wool felt, served as the foundational material for early weather stripping. Its cellular structure allowed for reasonable compressibility, making it effective at filling irregular gaps. Early felt weather stripping was often sold in long rolls, typically 1/4 inch or 1/4 inch thick, and anywhere from 1/4 inch to 2 inches wide. The installation process involved carefully cutting the felt to length and tacking it to the doorstop. Small flat-headed tacks, usually blued steel for some corrosion resistance, were used, spaced perhaps every 3 to 6 inches. The felt was positioned so that when the door closed, it would compress the felt gently, creating a barrier. The advantages of felt were its low cost and ease of manipulation. A homeowner with a hammer and a pair of shears could install it. However, its disadvantages were numerous and significant. Wool felt is highly hygroscopic, meaning it readily absorbs moisture. This led to several issues. 1. Degradation. Moisture could cause the felt to rot, mildew, or become brittle. 2. Loss of resilience. Once wet and then dried, the felt often lost its springiness, becoming permanently compressed and failing to seal effectively. Insect infestation. Natural fibers like wool could attract pests. 4. Short lifespan. Due to these factors, felt weather stripping typically required frequent replacement, sometimes annually. Despite these drawbacks, felt remained a viable, budget-friendly option throughout the entire 1900 to 1970 period, especially for interior doors or as a temporary measure. By the latter half of the period, synthetic felts, made from polyester or other plastic fibers, began to emerge, offering improved moisture resistance and durability, though wool felt still held a share for its traditional appeal and natural origin. These synthetic felts, however, typically lacked the inherent resilience and insulating properties of high-density wool felt, often necessitating a denser weave or thicker profile to achieve comparable sealing. Metallic weather stripping, 1900 to 1970, with evolving materials. This category saw the most dramatic evolution in terms of material and profile sophistication. Zinc, 1900s to 1950s, initially popular for its malleability and corrosion resistance. Zinc strips were easily formed into complex interlocking profiles or simple V-strips. It was more durable than felt, but could be prone to bending or denting under heavy use. Installation involved careful bending and nailing or screwing. The primary limitation was its relatively soft nature compared to bronze, and its somewhat duller, less aesthetically pleasing appearance compared to polished brass or bronze. Bronze and brass, 1900s to 1950s, with diminishing use in residential. These alloys offered superior durability, excellent corrosion resistance, and an attractive golden finish. They were often used in higher-end residential applications. Bronze spring strips were renowned for their resilience and long life. However, their higher cost limited their widespread adoption. Installation required more robust tools for cutting and shaping due to the material's hardness. The enduring quality of bronze meant that many early installations remained functional for decades. Aluminum, 1940s to 1970. As discussed, aluminum revolutionized metallic weather stripping. Its post-war availability and processing innovations made it an ideal material. Profiles. The V-strip was a perennial favorite, but aluminum also allowed for the creation of more complex extruded channels designed to hold flexible inserts. These profiles were roll-formed or extruded from aluminum alloys specifically formulated for good ductility and strength, such as 3003 H14 or 6063 T5. The typical thickness for residential weather stripping was around 0.015 to 0.030 inches. Installation. Screws became the standard for aluminum weather stripping. Small, usually number 4 or 6, flathead or panhead zinc-plated steel screws were used, typically 1/2 inch to 1/4 inch long. Pre-drilling pilot holes was often recommended, especially in hardwood frames, to prevent splitting and ensure a secure attachment. Aluminum, while corrosion-resistant, could react galvanically with certain types of fasteners, leading to localized corrosion over very long periods, hence the preference for compatible coatings or materials. Rubber weather stripping, 1930s to 1970, growing prominence. Natural rubber and later synthetic rubbers offered excellent resilience, moisture resistance, and a broad temperature service range compared to felt. Early rubber strips, 1930s to 1940s. These were often solid, extruded profiles, typically rectangular or square. They were either tacked, nailed in place, or, with the advent of early adhesives, glued. The quality and longevity of these early rubber compounds varied significantly. Natural rubber was susceptible to ozone and UV degradation over time, leading to cracking and hardening. Foam rubber, 1950s to 1970. Both open-cell and closed-cell foam rubber gained popularity. Open-cell foam, good compression, but could absorb water. Often used for less exposed applications or as part of a multi-component system. Closed-cell foam, superior moisture resistance and better long-term resilience. Commonly found in rectangular or D-shaped profiles. Installation. Adhesive backing became common, but early adhesives were less reliable than those of later decades. For added security, some foam strips included a fabric backing that could be stapled. The density of the foam was critical. Too soft, and it wouldn't provide an effective seal. Too hard, and it would impede door operation. Vinyl weather stripping, 1950s to 1970, rapidly gaining dominance. Polyvinyl chloride, PVC, was a game-changer. Its versatility allowed for a vast array of profiles, and its inherent properties made it ideal for weather stripping. Properties: excellent weather resistance, UV stability, chemical resistance, and a wide operating temperature range. It could be formulated in various hardnesses, durometers, to achieve specific compression characteristics. Profiles: solid strips, simple, cost-effective, but offered less compressibility than hollow profiles. Bulb profiles: hollow or semi-hollow rounded shapes that compressed to form a seal. These were highly effective, as they could deform significantly to fill gaps without creating excessive resistance to door closure. Bulb sizes varied from 1/4 inch to 1/2 inch or more in diameter. Stuff fin profiles: one or more thin, flexible fins extending from a base. These were designed to brush against a surface, creating a wiping seal. Multi-fin designs were particularly effective at creating multiple air barriers. Tubular profiles: similar to bulb profiles, but often with thinner walls, offering greater flexibility. Kerr-fin, integrated profiles. These represented a significant leap. A thin, rigid fin, or barb, extending from the main sealing element, was designed to be inserted into a routed slot kerf in the door frame. Once inserted, the barb would friction fit, holding the weather strip securely in place without visible fasteners. This method offered a very clean appearance and was particularly favored in pre-hung door systems. The kerf slot typically measured 1/4 inch wide by 1/2 inch deep, though variations existed. The sealing element itself could be a bulb, a fin, or a jacketed foam core. Nail-on, screw-on, adhesive-backed and kerf-in methods were all employed. Nail-on vinyl strips often had pre-punched holes and a semi-rigid base for easy attachment. Adhesive-backed vinyl, similar to foam, benefited from improving adhesive technologies, making it a viable DIY option. Installation methods and tools, generalized evolution. From 1900 to 1970, the evolution of installation methods reflected the advancements in materials and design, moving from crude, labor-intensive processes to more refined, efficient, and often DIY-friendly techniques. Early 1900s felt and basic metal, tools, hammer, tacks, tin snips, measuring tape, pencil. Process: felt was cut to length with shears, positioned and tacked every few inches. Metal strips required careful bending and cutting with tin snips. Alignment was often done by eye or rudimentary marking. Patience and precision were required, especially for interlocking metal systems, where slight misalignments could lead to binding or an ineffective seal. 1920s to 1930s. Tools: hammer, small nails, screws, screwdriver, tin snips, measuring tape, square, sometimes a specialized hand press for shaping metal. Process: spring metal V-strips were cut to length, positioned with care to ensure the V compressed correctly against the door, and then nailed or screwed. For screws, a pilot hole might be started with an awl or a small drill bit. The installer would typically close the door to check for proper compression before final fastening. Attention was paid to corners, which required careful mitering or notching of the metal strips to ensure continuity of the seal. 1940s to 1950s, aluminum and early elastomers. Tools: screwdriver, drill, metal shears, utility knife, measuring tape, sometimes a caulking gun for adhesives. Process: aluminum weather stripping, often with pre-punched holes, encouraged screw-on installation. This allowed for more precise adjustment after initial placement. Vinyl or rubber strips were cut with a utility knife or shears. Adhesive-backed strips required clean, dry surfaces for optimal bonding. Pressure was applied uniformly along the strip after placement. For channel and insert systems, the aluminum channel was screwed first, then the vinyl or rubber insert was pressed or slid into the channel. 1960s to 1970, vinyl, foam integrated systems, tools, utility knife, measuring tape, screwdriver, drill, occasionally a router for kerf-in applications, though often done at the factory or mill workshop, adhesive roller for contact cements. Process: adhesive-backed strips were common for DIY. Kerf-in weather stripping, while conceptually simple, required precise kerfing of the door frame or slab. This was often done during the manufacturing of the door unit. On site, it simply involved pushing the barb of the weather strip into the pre-cut kerf. Screw-on vinyl and aluminum vinyl combinations continued to be widely used, with increasingly refined designs for easier, more forgiving installation. Automatic door bottoms required precise cutting to door width and careful adjustment of the drop mechanism once installed. Factors influencing evolution. 1. Energy costs and conservation. While the dramatic energy crises of the 1970s and beyond truly cemented energy efficiency as a paramount concern, the underlying principle was present throughout our period. As homes became larger and heating systems more sophisticated, the cost of wasted heat became more apparent. Early 20th century homeowners appreciated the comfort, but by the mid-century, the economics of keeping a warm home warm began to drive demand for better sealing solutions. 2. Material science advancements. The discovery and commercialization of new polymers like PVC and improvements in the processing of natural and synthetic rubbers provided engineers with a broader palette of materials. These new materials offered combinations of flexibility, durability, and cost-effectiveness previously unimaginable. Manufacturing techniques. The ability to extrude complex vinyl profiles, roll-form aluminum precisely, and mass-produce foam strips at scale brought down costs and increased availability. Automation in manufacturing reduced labor costs per unit, making more sophisticated weather stripping accessible to a wider market. 4. Building practices and standardization. The rise of large-scale residential developments, particularly post-World War II, fostered a need for standardized building components. Manufacturers responded by offering weather stripping that could be easily integrated into common door and frame designs, reducing complexity for builders. While formal building codes didn't heavily regulate weather stripping in this era, the informal standardization of dimensions and installation methods emerged from market efficiency. Consumer expectations. As living standards rose, so did expectations for comfort and convenience. A drafty door was less tolerable, and the desire for maintenance-free components encouraged the development of more durable and longer-lasting weather stripping solutions, moving away from the frequent replacement required by early felt strips. 6. Aesthetics. While function was always primary, the aesthetic impact of weather stripping also played a subtle role. Early tacked felt was visibly utilitarian. Metal strips, particularly bronze, could be seen as an enhancement. The move towards kerf-in vinyl, which was largely concealed, demonstrated a desire for invisible integration that didn't detract from the door's appearance. Nuances and challenges of weather stripping. It's important to remember that the effectiveness of weather stripping is not solely dependent on the material or profile, but also on the precision of its installation and the condition of the door and frame themselves. Door and frame condition. A warped door or a settling door frame could create uneven gaps that even the best weather stripping struggled to seal effectively. The flexibility of felt, foam, and vinyl made them more forgiving of minor irregularities than rigid metal systems. Seasonal changes. Wood doors and frames are hygroscopic and can expand and contract with changes in humidity and temperature. Weather stripping needed to accommodate these subtle movements without losing its seal or creating excessive friction. Flexible materials excelled here. Friction and wear. The constant opening and closing of a door subjected weather stripping to repeated friction. Materials like felt wore out quickly. Metal systems, if misaligned, could cause metal-on-metal wear. Vinyl and jacketed foam were designed to minimize friction while maximizing sealing. Corner details. Sealing the corners of a door frame presented a particular challenge. Early solutions involved simply butting the horizontal and vertical strips together, leaving a small void. Later, more sophisticated systems allowed for careful mitering of metal or vinyl, or the use of preformed corner pieces for foam vinyl gaskets, ensuring a continuous seal. Threshold interface. The transition from the vertical weather stripping to the horizontal seal at the threshold was a critical area for drafts. Integrated systems of door bottoms, sweeps, and adjustable thresholds were developed to address this complex intersection, creating a more continuous barrier against air and moisture. By 1970, the landscape of residential exterior door weather stripping had transformed dramatically from the rudimentary tacked felt strips of the turn of the century. Homeowners and builders now had access to a sophisticated array of materials and profiles, predominantly aluminum, vinyl, and synthetic foams, installed with greater precision and often integrated into the very design of the door unit. The primary objectives remained consistent: to block drafts, reduce heat loss, and improve comfort, but the means to achieve these objectives had become far more effective, durable, and aesthetically refined. The seemingly simple act of sealing a door had, through incremental innovation, evolved into a quiet testament to material science and architectural engineering, forever altering the subtle relationship between our homes and the elements outside. This lengthy exploration has detailed the subtle, yet profoundly impactful shifts in an often overlooked component of our domestic architecture. Each small adjustment in material, each slight modification of a profile, each refinement in installation technique contributed to a cumulative improvement in the comfort and energy efficiency of American homes. The silent, almost invisible work of weather stripping continues to stand as a quiet guardian, protecting our interiors from the ceaseless ebb and flow of the outside world, a testament to continuous, gentle innovation.